So welcome to the server-side programming techniques in Firebird session. First of all, who is new to store procedures and triggers? Well, nobody. Well, the session is quite some basic stuff on PSQL, stored procedures and triggers. I've prepared quite some slides, so I think I could fill the entire session just with examples as well, but I think having some slides, especially after the conference, to look up or something like that, is quite a good idea. So if you get bored by basic stuff, just raise your hand. So we can also do some live coding. I've prepared a few examples which I intend to show after the slides, but if you have any basic questions or you would like to see examples or anything else, feel free to ask. Well, let's talk about why store procedures and triggers. Then we're gonna talk about the procedural SQL language. We'll talk in particular about store procedures, the execute block statement, triggers. I'm gonna present to you the PSQL enhancement in Firebird 2.5. And just a very, very short list, just one slide with the PSQL enhancements you can expect in Firebird version 3. First of all, well, if you're moving from Paradox or any other file-based database system, the possibility to execute program logic on the server is a very, very important feature compared to a file-based database management system. Well, why is it powerful? You can run code on any Firebird platform unchanged. So if you develop a database on Windows and you program store procedures, the store procedures are easily transferable to, for instance, Linux or something like that. So it's also making the same code for different connectivity technologies available. So if you're connecting with Delphi, with GDBC or something like that, and you have one store procedure basically doing your business logic stuff, then the store procedure can be run from any connectivity technologies. You can reduce network traffic a lot, especially if you're coming from a file-based system. You usually tend to fetch records, do some calculations, and do other stuff on that. So with the store procedure, you really can do everything on the server side. You can centralize business logic. You can improve query execution because server-side code is pre-compiled and stored in the database system tables. You can somehow build a data abstraction layer with stored procedures. So, for instance, if you outsource generating reports for a particular database, you can create store procedures to access just pieces of tables and fields, and the guys who are creating the reports don't have access, for instance, to the underlying tables or something like that. Well, you can ensure customized data integrity, especially if foreign key constraints they're nice, but usually if things are getting more complex, you usually end up with writing triggers, ensuring some customized data integrity. You can enforce business rules. You can do any server-side things like building a logging mechanism in the database. You can notify client applications upon certain events. So if, for instance, there's a new record inserted into a table and you want to notify clients about that, you're able to do that in PSQL as well. There's also a use case for data model checking routines. For instance, if you have a domain which basically defines your data type for a foreign key field, and I usually tend to do that way, and I often forget to define foreign key constraints on this field now. So I basically can write the selectable store procedure to give me all fields of the data type used for a foreign key constraint and just check if there's a foreign key constraint or not. So I can recheck my data model if it is in sync with, for instance, if there are any missing foreign key constraints. Well, you can create any logic you want with a procedural language. You can create your own functions without using an UDF. That's the main advantage here is that UDF needs to be compiled for the target platform. This means Windows, Linux, or something like that, and the CPU architecture if you're talking about 32 or 64-bit. The good thing here is if you're used to writing procedural code, then the language is pretty easy to learn, easy to use, but it's powerful and it's getting more powerful with each Firebird release. Well, for procedural language, as said, Firebird is able to compile and execute procedural code at the server. There are 3 types of code modules available: store procedures, triggers, and execute block. What happens if you issue a create procedure statement or a create trigger statement? Well, the source code gets parsed, optimized, and stored in property format called binary language representation in the system tables in the database. Well, and usually all PSQL code modules can be maintained by regular TDL statements, so you don't have to fiddle around with system tables or something like that. The language elements PSQL supports is pretty much the regular delete, insert, and update statements, and with a set of extensions to SQL, like local variable declaration. Some new stuff in new releases is, for instance, defining a default value or having a type of my domain, so I can reuse domain definitions in variable declarations as well. A new one is having a cursor declaration, so you probably are used to writing a for select for iterating through result set. There's also a new construct here available with using explicit cursor, like you probably are comfortable if you have used, for instance, Oracle or something like that. Well, there are control flow statements, if condition, while loops, leave break to exit a loop or exit the entire PSQL code module. There is also the post event statement for posting a named event, and you have quite some powerful exception handling. So whenever you think something can go wrong in a store procedure, something like that, you can wrap it in your own exception handling and react on some kind of SQL code, GDS code, or you even can define your own exception and catch that as well. You also can raise your user-defined exception, so with a probably more nicely reading exception message. You can execute statements which are dynamically built. So usually, if you have an input parameter as a table name as input parameter, and you want to execute it, there is no other way around that using the execute statement for executing a dynamically built statement. You can also, as DDL statements are forbidden in PSQL, you can also use the execute statement to execute DDL statements like, I don't know, adding a field to a table or whatever. Well, quite useful is getting the number of rows affected fetch by a previously executed statement in PSQL by using the row count context variable. And this works for both, also not only for delete, insert, and updates, but for select statements as well. Cursor support to iterate through result set is the commonly known for select close, or if you have a dynamically built statement for execute statement, or if you are using common table expressions, you can also use them in a for clause in PSQL. That's very useful, very powerful, so you can combine both worlds, common table expressions and store procedures and triggers. And you also have the Oracle-like style cursor declaration here with basically defining a cursor with specifying the select statement. You open the cursor, you basically have an infinite loop here fetching, and if row count, so if no records have been fetched with that statement, you are gonna use the leave statement, and well, you end up here with closing the cursor. Or executing stored procedures. Well, you can execute stored procedures in another stored procedure, even recursively. I think Frank has used in his tree-like structure thing recursive procedures as well. You can also execute the stored procedure, of course, in a trigger and also in an execute block. Stored procedures, only for stored procedure and execute block, you can have input and output parameters. And if you want to suspend something, or if you want to return the currently assigned return values to the client, and the client fetches the next values from the selected stored procedure, there is the suspend statement. Triggers only, you have access to the old and new field values by using the old field, new field context variables. The nice thing about the trigger implementation in Firebird is that you can have multiple before, after triggers for each DML operation in a user-defined firing order. You don't have that in Microsoft SQL Server, for instance. You don't have that in Oracle, especially. I think the user-defined firing order isn't possible to define. So that's really powerful. Just think about that one trigger is responsible for ensuring data integrity or some kind of business logic, and you want to have an additional trigger which encapsulates creating some kind of log records or something. So, for instance, in MySQL, there is only one trigger per event allowed. So to do that, you have to create one big trigger with both logic mixed up. So that's probably not the best idea. There is also a way to have a universal trigger. A universal trigger basically can fire on a delete, insert, end, or update. So you can have one trigger firing for all three operations, and to distinguish between which kind of operations was, there are these Boolean context variables to check for, to adapt your source code depending on the event firing type. Well, limitations in PSQL, regular DDL statements are not allowed, but yeah, you can do that with execute statement. There is no transaction control inside PSQL, so a PSQL code module always runs in the context of the client transaction. So if something bad happens in a stored procedure and you don't have an exception handling in place, the entire client transaction gets rolled back. So the nice thing, a nice addition here is in Firebird 2.5 with the autonomous transaction, that you're now able to use some kind of snapshots inside PSQL so that you can run code which gets committed even if something bad happens afterwards in the PSQL code module. So that's really useful. We will see an example on that later. Well, and for recursive stored procedures, I think I'm not entirely sure, but I think there is a hard-coded recursion depth at about 1,000. So. Well, that's basically a very, very quick introduction to PSQL and the language elements. Stored procedures can be called by a client application, whatever access components you use. A stored procedure can be called by another stored procedure, an execute block and trigger. For the input and output parameters, you can use simple data types, like an integer, or you can use, I think it was added in 2.0 or 2.1, you can use also domains. If you use a domain without the type of clause, then also any value checking constraints which are on the domain checked here as well. If you use only if you use the type of and the domain, then it's just the single data type definition behind the domain which is used here. And if you also can use parameters, input parameters with a default clause, but they have to be at the end of the parameter list. Basically, you have to differ between how you execute the store procedure. The one thing is executable store procedure. Usually, this is a procedure which doesn't return a result set. Well, it can return a list of output parameters, but just a single row, single line. So, well, it's usually used when executing DML operations. So the usage basically looks like it's just typing execute procedure name, and optional returning values clause with any local variables here on the right hand side. The other way is the other way are selectable store procedures, so they can return multiple row result set. So think of a view, like a view in the database, but much more powerful in respect to having your own code, your own program logic here. A selectable store procedure is used like a table, so you can simply do a select star from a procedure. You even can join that with another procedure or with table or whatever you want to do with it's pretty much using it like a table. Well, it's basically that's the structure. You have procedure header with create procedure name and parameter list and a procedure body. If executing a create procedure statement, you usually have the terminator symbol here used all over the place, so you have to use a set term clause to just switch the terminator symbol to something else. Well, that's a very simple example for executable store procedure. Basically, what I use in my databases regarding naming conventions is for executable store procedure, I use a p underscore. So just so whenever I connect to a database and I see such a procedure, I know I have to use that as an executable store procedure. What you have to do is, if we have a local variable here, if you want to use the local variable in a SQL statement, you have to prefix that with a colon. I'll simply omit the column in every other places here, for instance, here over here. So there's also one for the Delphi guys here. If you're used to writing Delphi code and you are probably writing PSQL the first time, an if clause, a while clause really needs the brackets here. So don't forget them. And also for coming from the Delphi world, in PSQL there is never a semicolon after an end. So that's quite some one or two things you have to keep in mind if you're coming from another procedural language. Well, and executing is pretty much execute procedure. There's typo, it should be p underscore to execute the procedure. A selectable store procedure, I use the prefix s underscore. For that, it's pretty much it could have input parameters. Selectable store procedure usually has output parameters. What I do here is just doing a select on RDB relation to iterate through the relations which are in the database, and execute use the execute statement to execute the select count star from the relation name. So I have one call of a selectable store procedure, and I get a result set of how many records I have per table. Well, the suspend statement here is pretty much then suspending the execution of the store procedure until the client application, the caller application, fetches the next record. Well, managing store procedures is pretty easy. You have regular DDL statements: create, alter, drop. Some release, the recreate was added, so It basically tries to drop the store procedure. There's no exception if the procedure doesn't fail, and it afterwards creates the store procedure. This doesn't work if there are any dependencies. So if there are dependency on the store procedure, then the drop operation will fail with an exception. There is also the creator alter. It's a bit more powerful than the recreate. It's simply if the store procedure doesn't exist, it executes a create. If it exists, the store procedure gets altered. So that's very useful for writing update scripts where you have to ensure that no exception happens when running the script. Well, and you have security, SQL security with a regular grant DDL statement, so you can grant execution of a procedure P to a user, to a role or something like that. And you also can grant, for instance, a store procedure insert operation on a particular table, for instance. So you have full power of security here in this area. Well, the debugging thing is, I think all of you use IB Expert. Most of you? No. The thing is, the Firebird engine itself doesn't provide any API or callback mechanism for tool developers for client applications to hook into the execution of such a store procedure. So to debug a store procedure, usually what third-party tools do is just simulating the execution of a procedure. So some magic behind the scene which runs the store procedure and allows you to, for instance, in case of database workbench, iterating through or processing the store procedure to a breakpoint or something like that. The nice thing about the debugging database workbench, for instance, is we also can debug triggers, execution of triggers. So you can run a trigger in debug mode, set a breakpoint, and if you manipulate a table, change something, commit, and you switch back to the trigger editor, to the debug mode of the trigger editor, you will see that you will end up at the breakpoint, and then you are able to step through. So also for debugging trigger, that would be very useful. Well, the execute block statement is basically whenever you want to run a PSQL code and you don't want to create the store procedure, or possibly you aren't allowed to create the store procedure, you are able to execute the execute block, which basically is pretty much the same with you could have input parameters, you have output parameters, and you have the full power of the PSQL language inside the execute block. So the example before can also be done by an execute block, simply taking the statement, getting into a SQL editor, pasting it into the SQL editor and running, and you should also get the result set as like if you're executing the store procedure. Well, triggers, of course, are a bit different. They allow you to automatically execute PSQL code upon certain events. Events are delete, insert, update, or with database triggers also on connect, on disconnect, on commit of a transaction, something like that. Triggers can call other store procedures, or triggers can call store procedures, and it doesn't make sense that triggers don't support input-output parameters. So also the nice thing about the Firebird implementation is that you can deactivate triggers without dropping them. So that's in particular use cases very, very useful. And the ability to have multiple triggers for the same table timing operation is by using the position keyword is very useful as well to define a firing order of your triggers if you have more than one on the same table timing operation. Well, and there are two types of trigger if we are talking about Firebird 2.1 and 2.5. Table triggers have been in Firebird since the beginning. In Firebird 2.1, database triggers have been added. So table triggers is pretty much, you probably know. The main difference is if, for instance, if you're coming from Microsoft SQL Server, that Firebird triggers are row-based. So if you execute an update statement which involves updating 1,000 records, then the trigger gets fired 1,000 times. In Microsoft SQL Server, that's different. There you have statement-based triggers. So if you're issuing an update statement, the trigger gets only fired once, whatever the number of records are involved from the update statement. Well, what I really like are universal triggers. I think they have been added in Firebird 1.5, which allows you to have one trigger for all three firing operations. Well, usage scenarios can be auto-increment, maintaining uppercase, shadow fields. You can have enhanced data integrity, checking enforced business rules. If you have views, you can make them writable, updatable by creating triggers on views. Well, you can notify client application upon certain events. The structure is, you also have a trigger header, trigger body with different syntax, with, creating trigger active, inactive. Yeah, I think it's pretty obvious. Very simple example, I think everybody knows that. What I used to use for naming conventions for triggers is I'm using pretty much tr underscore. If I'm creating an auto-increment trigger, then usually I also suffix the thing with underscore ID, for instance. Just if I have a lot of triggers here, I know exactly by the name what's the business of the trigger. So, well, the field change notification, for instance, is pretty much there is distinct from clause. I think it was added in Firebird 2.0. Basically, it allows you to check if something has changed, if you're using old field name, new field name. In previous versions, you had to deal with nulls, so you had to write old value is null or blah 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 is not null and the other way around, and it's different. So that extension here for checking if something is unequal is very, very useful. Especially, it also works for blob data. So while you have been using, for instance, to check if something was different in a blob with user-defined function, for instance, using a CRC check or something like that, you now have the is distinct from clause beginning with, I think, Firebird 2.0. Well, that's an example of a universal trigger. So basically, that is, I have 3 additional fields which basically extract the day, the month, and the year of birthday of a person and stores that in separate fields, which probably then get indexed so that accessing or using the fields here in the where clause is fast enough. So that's pretty easy with an insert or update trigger. In previous versions, you had to use 2 triggers, possibly having the same code here under 2 triggers. So that's it makes things easier as well. Well, the context variables, old and new, depending on the operation, old and new is available or not. What's important here is that the execution order in respect to having the before trigger and after trigger and user-defined constraints, for instance, check constraints or something like that, is usually this one. First the before trigger fires, then user-defined constraints get checked, and then an after trigger gets executed. The thing here is that in the very old interface 6 days, I think the execution order was sometimes mixed up, switched a bit. So there was possibly a way to to overcome a user constraint by adding some data which violates the user constraints without getting an exception. So that was a very bad situation. Well, database triggers are new since Firebird 2.1. Basically, they aren't bound to particular tables, but to database-wide events. The events supported are onConnect, onDisconnect, onTransaction start, commit, rollback. I think Holger mentioned an example where his download center was pretty bad in respect to performance because he used to create the onTransaction commit trigger doing some stuff in there. And so while they are very powerful, they might be called a lot. So use them with care. Well, you could also imagine, we will see an example later on, if in the onConnect trigger, if you write an onConnect trigger and you write some bad code, you could imagine that, well, the trigger prevents me from connecting to the database at all. So, for instance, ISQL, the command line utility, has a special parameter. If you use that option when executing ISQL, it simply omits executing database triggers. So that's a way to get into the database as well and possibly either fix or drop the bad database trigger here. Well, for instance, what we have here is usually I tend to create my databases not as sysdba, but as another user, and especially, for instance, when developing the database, the user you have used when connecting to the database is usually the owner of creating new tables. So if you don't be careful in that way, what user you use when connecting to the database at development time, you really can end up with quite some strange situations if there are different owners of tables and so on in your database. So one way you could overcome this with at least Firebird 2.1 is to have a user-defined exception. Simply can run that, and an onConnect trigger. Then pretty much ISDAP is the owner of the database, and if the connected user, the current user, is different to this one here, I simply throw my customized exception and I will disallow connecting a user different to the database owner here. Well, managing triggers is again very, very simple with regular DDL statements. Create, alter. The alter statement, you can set a trigger active, inactive without providing the trigger body. You can change the position of the trigger without providing the body. You can only change the body, and if you change the header and the body, well, the trigger gets replaced. You can drop a trigger, recreate, create all trigger. It's pretty much the same in stored procedures, as well as the security part. Well, the new things here in Firebird 2.5 are autonomous transactions, cross-database queries, with the execute statement, reusing field data types and subqueries as PSQL expression. We will look into that on the following slides with an example. For instance, if we extend our example with dismissing particular users when connecting, we could have an in-autonomous transaction block where we pretty much insert some data into our connection log table with the client address, the action text. It's, for instance, prohibited because we're in the unequal path here, and a message text. So what you can do here is that if you reach the end statement here without an exception, at this point, at this end, this block here gets automatically committed without committing the output transaction. So that's very useful, especially for logging stuff or something like that, because without that construct here, throwing an exception here would roll back the entire client transaction, and you won't have any log entries in the connection log table, and the entire transaction will be rolled back. That's very, very useful. Well, the other thing is that the execute statement got extended in some ways to query other databases which can reside on the same server or which can reside on another server. Basically, it's again the execute statement here, but with an additional on external clause where you specify the database path as user. You can use, for instance, the current user context variable here and the password there. This way, it's grabbed into a for statement, so you pretty much can query data from another database and pretty much returns that to the client application. What I also find quite useful is that, especially again if you're coming from Oracle, for instance, that data type definitions can be either simple data types, you can use domains. What you now also can do is you can write type of column and really specify a table field here. So if you want to have the concrete data type of a relation name in the system tables, you now either had to use a varchar 31 or a user-defined domain, or now you are able to do that by providing the relation name and the relation name, and it gets automatically the data type assigned here. Well, subqueries can now be used as PSQL expression. Well, it's a matter of taste, so you could use, for instance, something like that, a local variable and a subquery here, executing and assigning the scalar value to the local variable. In previous versions, you had to use the quite known into statement somehow. So, well, it's just a matter of writing code a bit differently. Well, that's the enhancements to be expected at least. I think Vlad told them already that the 4 bullets you see here is already committed to head. So what we can expect in Firebird 3.0 is Java stored procedures. So you can write Java code and use that as a regular stored procedure. You can have stored functions, which basically allows you to fully replace any UDF, for instance. So you can really define a stored function as such that you will get back one scalar value. We will have packages. Packages allow you to organize your stored procedures in some way. For instance, the ERP system Averb, I think it has about 3,000 stored procedures in the database. I think they might benefit when grouping a stored procedure from the logic into some packages, so it will be more readable. And last but not least, DDL triggers, which basically will fire if you issue a create statement or an alter statement or something like that. You can define a trigger on that and react or log something to a log table or whatever. Well, that's pretty much the thing about the slides. Are there any questions? Or are you used to store procedures and triggers already that much that, well, there's nothing new to learn? Yeah. I think I'm lucky here because, yeah. If it was the number what you have said, then there's a typo in my slide. So do you remember where the slide was? This one here? Yeah, that's the maximum value. So you can have quite a bunch of triggers on the same event type. Yeah. Yeah. Well, an example about common table expressions. Let's see. Well, I'm not sure. Let's have a look. Well, basically it's about tree-like structure when storing regions. Well, you know, continent, country, some kind of state and city. With the common table expressions in PSQL, it looks like that way. So you have the regular for clause. Simply put the with clause here without semicolon here, and simply issue the select statement after the common table expression. So it's pretty much the same than executing the with clause in a SQL editor. But if you want to iterate through the result set here, you have to use the for clause. So that's really powerful. So let's see if we want to know all regions, for instance, Austria and all sub-regions, we have to call that with an ID of 6. And yeah, we are done with the hierarchy additional field here. So that's, yeah, quite useful. No, it's exactly the same statement, except that, well, let's give this one a try. I simply open a SQL editor. I paste the SQL editor here, and I think I have one parameter here. So let's execute this one here. And enter 6 and execute it. Get very much the same result. Yeah. Well, yeah. For instance, are there any other questions or examples you would like to see? Well, with the common table expressions, you can, if you have a recursive data structure like regions, sub-region, and again sub-region, something like that, you can, with the with clause and an additional clause recursive here, you can query those tree-like structure very easily. So Frank did a two-part session on that. There are two ways. Either without the with clause, it's the only way is to have a recursive selectable store procedure, probably written to traverse the different levels here, or it's with the common table expression. So the with clause here is called common table expression. It's very easy to query recursive data structures. Yeah, and you don't have a maximum limit of about, I think, 1,000 recursive. Okay. Yeah, well, let's see what, for instance, for data model checking, as said, I'm using, for instance, let's see, device. Device is linked to a device type. I usually tend to use domains all over the place, so that the table definitions is keeping readable. So what I can do here is with, for instance, a selectable store procedure, which basically is this one here, is just querying the right system tables, and I simply look if this guy here holds the domain name. If I find table fields without a foreign key defined, I get a list of them, and I know I had missed, or I had forgotten to create the field foreign key constraints. That's especially when developing databases very useful. The list here is now empty, but if I create, I don't know, another one here with field, and it's again ID ref null, for instance, commit this one here, go back to my stock, and I had forgotten to create my foreign key constraint, and I go back here and click refresh. I know that, well, there is one foreign key constraint missing, and I have to create that. So that's, well, it's some kind of usage of a selected stored procedure. The other thing here is, well, that's pretty much the same implementation of traversing such a recursive structure with a recursive selectable stored procedure. It's a bit more complex. You have the things like the left join getting right, and so I, for one, prefer pretty much the common table expressions performance-wise, and also from being able to read the code. So, but it's possible with a recursive selectable stored procedure as well. Another thing here is this one here is the example of querying an external database. I'm in, well, from data warehousing session, I'm in my transactional database. I want to query something from my analytical database. I think I have to just import here. If I want to execute this one here, I'm able to get a result set from another database. So that's currently the SQL-wise, currently the only way to query an external database. We don't have any database links yet, something comparable to Oracle, for instance. What I also tend to use is, well, as I said, this one is pretty useful as well to get an overview on how many records do I have in particular tables. The implementation here uses a regular for select statement. We can also do that in some kind of Oracle style here by declaring a cursor with the SQL statement, and well, having additional constructs here for working with the cursor here. What I also have sometimes is if you have any common fields you use, like, I don't know, creation timestamp or something like that. So fields you usually should have in each table, if you use them, you could write something like that which automates the task for creating that by, let's see, by using the execute statement. For instance, well, we will see here a stored procedure querying another stored procedure. This procedure here basically gives me all user tables in the database. So with this one here, I'm pretty much, I don't want to execute this one. Pretty much get a list of created fields, common fields in all of my tables. So if I add this one here, well, I think there's something wrong, but the idea is pretty much that if you are using the execute statement, you can really do nearly anything. So, well, other examples is like what I usually tend to use in databases which are in production is to recalculate the statistics of indices so that the optimizer is able to choose the correct index. So what I have here is a selectable stored procedure which basically goes through all indices and executes the set statistics index on the index name, and pretty much gives it back analyzed, or if something fails, we have an exception handling here, the failed flag gets returned, but it due to the exception handling, the for select cursor won't be executed. So if I'm gonna execute this one here, you will see that basically all indices in your database, the statistics get recalculated. So if you do this from time to time, you should get good performance in respect to the optimizer. Well, yeah, there could be a lot more examples. I think the time is pretty much over, but you know, with the aggregate table stuff I've presented in the data warehousing session, you have really the full power to somehow implement your own aggregate table syncing mechanism here by using stored procedures. So things might get a bit complicated. Well, but it's just a piece of code, yeah. 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 I like that a lot, yeah. I mean, no. I think what you should not do is using suspend in an executable stored procedure. But I use selectable stored procedure pretty much for everything in respect to executing TDL statements and returning. I mean, that's the only way to return some kind of status, what happened to when executing the execute statement. So I've never encountered a drawback of that. So. Yeah, well, if there are no other questions, yeah, thanks. Yeah. That's, yeah. Let's see. Well, the thing here is that I don't use the installer, but the zip distribution. So what I tend to use is just, I don't know if, yeah, that's the user authentication, whatever. Let's try. I think that should be possible with this one here. I usually give it a serious name with Firebird, the version, port number. And then I pick up the zip distribution. It's 64-bit, so get this one here. Open it. It this way. The Windows Explorer. So I'm gonna copy this one here. Go back to the directory. Put the files in here. Then you also could choose, well, depending on the architecture. So if you know what architecture you want to use with this particular instance, you probably could give it this suffix for superclass, for instance. Then you have to go to the firebird.conf file. Well, that's again the user authentication thing. So let's open this one here. Oh, that's cool. Did you remember the directory? Look for, you better look for 3050. So you will have this entry here. You're gonna change that one to this one here, to the port. And basically, this is all you have to do in respect to configuration. For presentation, yes, or yeah. I mean, if you have enough memory, yeah, why not? No, I think what you have to be careful is if you had been using the installer before, the installer creates a registry entry, I think, which basically also points to the place where the firebird.message file is used. So you'd better either don't use the installer or remove the registry entry and use the zip distribution for installing. So what you can do now here is you have to adjust this one here. The other way is you also could you also could you also could provide the thing, if you want to run it as an application, let's make it this way. Or if you want to run it as an instance, as a service, you go into this here. So basically you then have to choose what architecture you want to install. Well, in our example we use Super Classic. And then you can provide a service name here. And I usually tend to use exactly the name as the directory name. So this way you get a named instance installation. So if you are looking into the services panel here, we will see a new instance here called this one here. Running the server as a service is one way. For example, for quick demonstration or something like that, you could also run the server as an application by using it's I just type it here, FB server. In case of Super Classic, you need the M switch A for application, and you also could provide the TCP port here, for instance. So if you are if you are creating a shortcut somewhere with exactly this call, the Super Classic server gets started listening on TCP port 3060. No, it's pretty much in respect to the TCP port. It's simply much ignoring the Firebird.conf file. So there is an evaluation rule for the TCP port. I think providing the TCP port with the P switch here is overriding the thing what is in the Firebird.conf file. Any other questions? Well, yeah, with the stored procedures, it's like, I don't know, having experience with something else. So hopefully it was one or another slide new for you. So yeah, thank you very much and enjoy the last sessions.